Please welcome Dave Shackelford.
Hello, people. So good to see you all here today. I actually can't see you at all, but I trust that you are, in fact, here. This is probably going to be the best hour of your lives. No pressure or anything, but just want to set it up. So thanks for coming, and of course, hopefully you're in the right place. We're going to be talking about cloud security and specifically around some architectural concepts and principles that I've gleaned over the years working with organizations as a consultant. Also, obviously, as somebody that teaches this stuff to people for SANS, I've sort of seen it all, heard it all. There's lots of different things happening out in the industry. In fact, just taking a look at a lot of the other talks that are going on here, and certainly some of the technology providers that are showcasing things. I mean, cloud is it, right? Cloud is happening, and I think everybody knows that. But what I want to talk about is not so much one specific aspect of technology or another. It's really more the entire big picture of it, and looking at how we can develop and design a better model for putting together some of the different clouds we're trying to. And unfortunately, what I've found is that we really don't have a lot of great guidance out in the industry. There's some efforts to sort of go in this direction, and I'll get to that in just a moment. But there's really a dearth of generally accepted best practices and principles. If you talk to one cloud provider, they've of course got some of their own. And another cloud provider will maybe echo some of those concepts and some of those different architectural principles with, of course, their own spin on it. But there hasn't been a generally accepted model. I don't know that I'm going to have one either, just to be clear. But I'll give you guys some of the things I've seen as I've been working in this space that I've found the successful teams have actually done. And I think that's the key here. I've seen some absolute dumpster fires in the world of cloud security. I've also seen some people that have done it pretty well. And I'd love to tell you the entire dumpster fire, hour here. That would be a lot of fun too, but that wouldn't necessarily be as useful. So let's make a move here. Okay, so this is probably one of the few generally decent working groups I've seen sort of focusing in on this. And for those of you that are familiar with the Cloud Security Alliance, you've probably run across this in your travels. And so the Enterprise Architecture Working Group has made some strides. They're trying to get together and say, okay, guys, if we got to come up with some reasonably decent guidance that we can give people. In other words, hey, look, if you had anybody sitting in front of you, regardless of their maturity level or where they were in the trajectory of building out a cloud sort of environment and moving workloads into the cloud, what would you put into this thing? And so they came up with this sort of exhaustive list of stuff. And if any of you have ever gone to one of my talks, I have this incredibly bad habit. It's a terrible habit. I know it's a bad habit. I seem completely incapable of stopping myself from doing it. But I tend to stick way too much stuff on slides. Brace yourselves, right? So I said, look, I'm just going to cram all these things into a couple slides and we can talk about them a little bit. So here they are, right? So boom, wow, too many bullet points. Anybody that ever says, hey, here's how to build a slide deck, this is what they tell you not to do. So don't gaze at this too long or you'll go blind, right? But if you read these things, and I'm not saying that you should stare at this and read every single bullet point, and I'm certainly not going to do that. What you'll find is that feels, sort of smells like common sense, has this general perception of common sense out there, things that many of you have probably done for years in whatever various part of the security industry or security operational space you work in. Awesome. So these are good best practices. Hey, maybe we should try to use things like federated identities. Okay, cool. I think that's a reasonably sound decision, and I'll actually come back to that here in just a few minutes. Maybe we should try to, ensure that we have sound identity management principles in place for the entire spectrum of what we're building. Again, good idea. Let's put some defense and depth in there. All good ideas. So again, here's another side of this. This is just the whole list of them. I actually tried to get them onto one slide and then was sort of disgusted with myself, so I broke them in half. But if you take a look at some of the things here, it's going to say, hey, look, make sure you cover the network. Make sure you cover the operating systems. Make sure you cover application security, blah, 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 on and on. Okay, let's pause there for a minute and think about this. If you put those things together as a general list of best practices, I think we'd all probably agree, yeah, makes pretty good sense. But I have a problem with what this working group came up with. It's not these. It's not the bullet points. It's not the best practices. It's not the feel-good sort of mantras that we can all cling to in the world of information security and assurance. Nope, that's not what the problem is. You guys want to know what the problem is? Of course you want to know what the problem is. I've built it up now. So here's the problem. It all comes out to that. And so if you go back to people in your organization and go, thunk, here's this. Here's what we're going to do. What does this actually mean? So I sort of laugh when I see this because, granted, okay, we can go through this whole thing and say, well, let's sort of pull out things that we like or that make sense. And if you squint hard enough, and please don't, by the way, there's just no sense in doing so. And all of this stuff is available for free on the Cloud Security Alliance website. So feel free to go get it at your leisure. That's great stuff. But when you look at this thing, when you take a look at this thing, what you're going to say is, how do I use it? Like, what do I do with this? How do I actually bring this into a more applicable manner of designing and building out a cloud? And actually, my running joke on that slide, and let's go back to that slide one more time just so we can gaze upon it yet again. Some of you know what I'm about to say here, but you never go to a conference room in your organization or another one where somebody's printed this thing out on like a huge, big piece of paper with colors and puts it up on the wall. And it's supposed to represent the thing you've been working on for the past 7 months or something. Maybe that's the move. You guys go back and go, this is it. I got a 7-month thing that I can, basically just mess around with. I'm kidding, don't do that. But point is, I don't know what to do with this. Nobody seems to know what to do with this. Let's move on. This is the other one that I sort of like, and I'm not trying to single out AWS. They've got a lot of great stuff out there. So does Microsoft, so does Google. Most of the major providers have published some reasonably good guidance on how to build things, obviously with a bent towards their own cloud, as you would expect. I don't think there's anything wrong with that. But I do like the well-architected framework from Amazon for a couple different reasons. Number one, it's evolved. So when this started out, and I've actually spoken with a few of the people that are on this team at Amazon, they're keeping up with things. They're not trying to stay static as this is, the foundational best practice that never changes or moves with the times. Of course it has to change and move with the times. And if you look at the big pillars, as they call them, that are associated with the well-architected framework, there are things that are changing in all of those different areas. So they're talking about reliability. Of course, we're seeing shifts in load balancing models, and we're seeing shifts in how you design, multi-regional cloud architectures. Of course, you're going to look at those things. You're looking at performance efficiency. You're obviously trying to spend as little money as possible while still getting whatever it is you need. So you need to make sure costing is a part of that. That's not our discussion here, so we're not going to spend any time on those things. But security is one of the pillars, and I have, in fact, tracked the changes that these guys have enacted within the well-architected framework in the security arena over the past several years as it came into existence. And they've done a pretty good job of keeping up with some of the big shifts we've seen, let's call it the last 5 years in the industry. And some of those shifts most definitely translate into what I'm going to be spending a little bit of time talking to you guys about now. So that's my whole intro spiel about where things have been maybe in the industry, but it's still changing. You guys know this, right? You guys walk out of this talk, and next week somebody will come out with something amazing, and off we'll go again. But I like those ideas, and I think we should all do our best to keep up with what some of these providers and industry groups are publishing, just if nothing else, to give us some ideas and compare them against some of the things that we're doing. I always look at some of these concepts and say, well, which are the ones that we have to have? Which are the ones that are nice to have? Are there any that you would argue are maybe sort of immutable? In other words, you really have to have this stuff in place. You've got to make sure that you have these core concepts in place, or you're just not going to be able to design cloud very well. My argument is yes, indeed, and I'm going to give those to you now. So this is something that I've been working on as a SANS instructor for a couple years. I've been actually sort of affiliated with the cloud security side of SANS courseware, authorship, and teaching since its inception. And so I've really worked very hard to not just get up in front of people and have these conversations, but get a lot of feedback from students as I've been working with them and talking to them, because every single class I teach, I get feedback from people that helps me see different sides of things, or maybe I get introduced to a new tool or product or architectural model or design that I can start incorporating into some of the things that I do and teach and talk to people about. These are the ones that I have seen stand the test of time. Over the past couple of years, for those that are doing cloud well, these are the concepts that I really like to bring to the table and talk about. So let's do it. Let's just jump into it right now. Number one, build in security at every layer, okay? This is the Captain Obvious moment of the presentation, because every one of you that has been in the security industry for any length of time has heard the whole defense in depth story, and you probably hear it who knows how many times every year. This is the idea of self-defense or defense in depth for all of the different layers that you're building. And we've been talking about this for decades. It doesn't go away just because you're building cloud. And in fact, one of the things I've discovered as people are designing cloud architectures is that it can sometimes feel a little bit disjointed from the security side of things. If you're talking to a DevOps team or to a cloud engineering team, those guys probably have it, pretty well together and they're having discussions. But when security gets involved, where do I actually put my controls? How do I make sure that I've got the appropriate level or types of controls for the design that we're actually working on? And that can sometimes be a little bit confusing. So you do actually have to break down the concept of a software or infrastructure as a service stack and say to yourself, what are the types of things that I want to see or need to see invested or involved in those? Now, this is sort of my throw it up against the wall and see what happens slide. And for any of you guys that have been doing cloud for any length of time, you know that there are some places here that we just don't really have the level of access that we've normally had. And in particular, the bottom layer of the stack stands out pretty clearly. The hypervisor is not something that any of the cloud providers are at all inclined to give you access to or control over, and I don't necessarily see that changing quickly. Now, there are some really cool things happening in hypervisor design. In fact, if you go look at some of the stuff that's been brought about with Amazon recently and some of the different designs that Google has been doing recently with their KVM architecture, locking it down and so on, there's a lot to say here, but nonetheless, still stuff that's entirely or almost entirely under their control. They're not going to probably cede that to you anytime soon. So I do think that that's a critical layer. If we could just go back to that slide really quick. Thank you. You got to make sure that they're locking things down, following some reasonable best practices, whether that's CIS benchmarks or whatever you actually choose to go along with. That comes down to things like questions and finding out what their risk profile is and all that stuff. Everything else above that, you've got some amount of control over in all of the major infrastructure as a service providers today. You've got DDoS defenses, either those that they provide for free or those that you can purchase separately. You've got different types of routing and sort of access control models, many of them software defined and infrastructure as code, along with the use of vendor appliances and products. In the data side of things, and by the way, data is not really a layer, it's just everywhere, so we have to include it here. It's things like redundancy and backups and encryption. We look at things like operating system security, which we've been dealing with forever, getting up into applications and so forth. Again, I'm not going to go through all this, but every one of those things that you've traditionally been accustomed to, today, I'd argue you have an equivalent in the cloud. It might not be the same thing. It might not be the same product. It might not even work the same because you're dealing with more API-driven or automated types of scanning, for instance, that is a little different than what you've traditionally done in your own house. Or you're integrating with some tools or services that are native to the cloud provider, and that's not inherently something you've had in-house, of course, at all. But you can get these, and that's the big change that we've seen. There's a couple other pieces that go along with this that I won't spend too much time delving into inherently just because there are lots of other talks that delve into them in a lot more depth. But defining security in code is the future. And so regardless of what feels maybe a little buzzwordy to you if you're out there hearing the DevOps and DevSecOps discussions that are being had, that is where it's going. It doesn't mean that's the only place you're going to find that. So you're still going to be dealing with firewall rules probably for the foreseeable future. You're still probably going to be dealing with log and event data that you've got to parse and sort of chew up and look at and so forth. But when you're starting to look at templatized design, for operating system images, for the definition of how your infrastructure is constructed and interoperates. If you're looking at things like software-defined interconnectivity between pods in Kubernetes, whatever the case is, all of that is built into some form of template. Security's got to be a big part of that. So that might incorporate several different layers. You've also got to make sure you're thinking about automation. I'll come back to that in a minute. Not entirely. I think that's a misnomer in the industry, is that if you're not automating everything, you're failing. It's just not true. You do not have to automate everything, but you should be thinking about the right things to automate and looking for new opportunities to do so, because manual just isn't going to cut it forever. So I'll get to that here in a second as well. But these are some of the key concepts you'll hear being discussed in the world of DevSecOps. This is not inherently just a DevSecOps talk, so I'll only focus on the pieces of it that tie into the architecture. One of the big changes we've seen over the past couple of years with the way that cloud is built is this concept of components. And this is a little bit of a weird idea to wrap your head around as a security professional when we've had things blinking in racks for a long time. I did a lot of work in virtualization, and I saw people start getting away from that physical design concept quite some time ago. So I think we're all fairly comfortable with the idea of, say, virtualized appliances or virtual assets or software-defined things, networking being probably one of the most prevalent. But when we start talking about components, that's not quite the same thing. And here's what I mean by it. For any of you that have ever done any programming with object-oriented types of programming languages, one of the key hallmarks of why that was considered an advantageous approach to programming when it was developed years and years ago was, look, you can write a function one time and then reuse it. So you can build something and then apply it in numerous places without having to recreate it time and time and time again. Great idea. Not just for efficiency, but I'd say also for stability and security if you did it right, because you could define a function, make sure it's a good function, hopefully, and then anytime that function gets invoked, you know that it's one that's been approved, vetted, etc. Well, we can do that now with things that we're building in the cloud, because you can start defining things or objects in the cloud that can be vetted, evaluated, approved, and then implemented in places continuously over the entire spectrum of how your cloud gets put together in the first place. So, good example. You design a security group in AWS or a network security group in Azure or whatever. You get it right one time, you put a label on it so that you know where it's supposed to be associated. It can be invoked and assigned to assets over and over and over again. You don't have to go create it again every single time. You design it once, you invoke it later. Same thing can be done for identity management policies, and that's something I'll talk about here momentarily as well. Identity management is really becoming the linchpin of cloud security in a lot of ways. But if any of you have ever spent any time designing some of the policies, especially in places like AWS, it is incredibly easy to screw it up. I know this because I have screwed it up. So if I get it right one time and I make sure it works appropriately and I really work to get those least privilege aspects in place, I really don't want to have to do it again. So do it once, invoke it whenever you need it. So that's the idea of components. And it really comes into this notion of centralization and centralized control that we've got to strive for if we're ever going to succeed in the world of cloud security. There's no way we're going to get there without really sort of embracing this concept. And I'll take this even further and put it into what I call the multi-cloud problem. And maybe it's not a problem. A lot of times for security professionals, it feels like a problem. Because the minute you guys get good and comfortable with some place like AWS, I'll just throw them out as an example, right? So you're like, I got this, I've looked at all their documentation, maybe I've gotten a certification from those guys. Somewhere in your house, Microsoft salespeople are taking your folks to lunch. And guess what? That's how it begins. And the next thing you know, you got some stuff in Azure. And then all of a sudden you're going, well, how did this happen? And then the next thing you know, Google's a part of the conversation. Again, this is how it begins, but that's really the nature of business today. If you're completely invested wholly in one cloud environment today, don't get too used to that. There's a lot of business drivers that are pushing people to adopt multiple cloud providers. And if you're really thinking about a tool or a service or a specific control that is wholly centric to that one provider, then you're going to find yourself locked in and in an incompatibility situation very, very quickly. Take a step back. Think about components, but think about components that can ideally be adopted or adapted to more than one cloud as an architectural principle and design model. And what that means is that if you're saying, hey, we are really good right now with Microsoft's Azure Resource Manager templates, or we are really good right now with Amazon's CloudFormation. Like, I got it. I know the syntax. I got everything designed. The minute you get all your CloudFormation stuff lined up, and somebody spins you out into Azure and you got workloads there now, you've got to go back and say, all right, how do I adapt this to work over here? And there might be tools or services that allow you to do that a little bit more effectively. This is just an example of a tooling mechanism that is gaining some traction in the industry. I threw a few names up here, but believe me when I tell you I don't have a preference. I'm certainly not endorsing any one of these providers. You should go do your own diligence on these kinds of things. They tend to be very expensive, and they can certainly be also problematic in a different sense because you're solving one problem, maybe. You're saying, hey, look, I got 3 different clouds I got to go deploy into. I'm going to go find a provider of some sort that facilitates me doing deployments into each one of those sort of unilaterally through a singular interface or design strategy. Rocket. Sounds awesome. Until that provider goes out of business or you decide you hate them for whatever reason. So the notion of vendor lock-in has a lot of insidious little facets that creep in at the edges when you start thinking about this concept of centralization and bring you back to the idea that, well, at some point you still might be forced to go back to the drawing board and really think through designing independently or uniquely for one cloud or the other. This is an idea that really a lot of security people struggle with. And I think the reason we struggle with this is because the term failure sort of means something different to us, you know? If somebody says failure for security people, we have this litany of terrible stories that we can tell and horrible experiences that we can share and data that's been breached and sadness that has ensued and so forth. Well, that's not at all what we're saying here, but we're still thinking through what can happen if, ... So this is really thinking ahead, ideally, if you're doing it right, and saying, look, I expect things to fail. I know that things are going to fail at some point. Let's figure out how we deal with it when it happens. So we are, once again, back to architecture principles saying, hey, look, what happens if somebody accidentally deploys the wrong image? So we updated an image that all of our systems are going to be spawned from, and it's not the right one. Something's wrong with it. Or somebody accidentally screws up one of the security group definitions somehow, and it's more open than we want it to be, and we've got to roll it back. What happens if we have an elasticity issue? We screwed up some of our load balancing parameters, and we didn't appropriately scale into the availability zones that we need to. You can just go down the list. In fact, this is something that security people are very good at. If you get a bunch of security people in a room together and say, okay, figure out all the stuff that could potentially go wrong, we have a great time with that. In fact, that's why we're not popular at parties. But if you go back to the idea of designing for failure, what it allows you to do is think through how you could, number one, detect it when it happens, and number two, flip it into a state that is no longer failing. And so there's this entire idea out there that I'm sure some of you are at least somewhat familiar with today. It's called chaos engineering. And it started with some of the folks over at Netflix and Salesforce, and certainly here in the Bay Area, that's not anything that people are unused to hearing. But this concept of chaos engineering takes it sort of to a whole different degree. The idea of chaos engineering is, let's just rip it up and see how well we do. And of course, you can do that in a measured way. You can also just sort of let things go and find out how bad it could ultimately be. But you're in fact imparting chaos. Let's shut that down and see what happens. Let's make sure we fail this device or this platform or this particular configuration to see how well we detect it and we actually respond. And you have to do this at 2 unique levels. So there's the component level, we screwed up a security group. We screwed up an instance image that we have sitting out there, or an AMI, whatever. Those are the different components. There's also the entire infrastructure. So the East Coast is gone. Now what? What happens if all of a sudden half your availability model is not available at all? Do you actually fail over? Can you, in fact, test that without sweating it really badly? And speaking as someone who has sat through just an enormous number of painfully, horribly boring disaster recovery testing situations, nobody ever really wants to completely pull the switch, right? Everybody sort of tiptoes around it, and usually it ends up being a glorified conference call where we do a lot of what ifs. But at the end of the day, how do you actually test this, and how can you ensure that you are capable of failing at a component level or at maybe a larger level? So there are tools out there that can help. There's also just a mentality that comes into place when you start designing architecturally for cloud, saying, as we piece this together, as we put together our infrastructure templates, as we start thinking about how we're going to deploy this, what happens if the process fails or something in the cloud provider environment fails that maybe we didn't even have any control over in the first place? So you've got to think at both of these levels, and you've got to certainly also think about cases where the cloud provider has a problem. Every major cloud provider has had a problem of some sort, and I could regale you with examples. Most of you guys have probably heard of at least a few of them in the past couple of years, but nonetheless, there are plenty of them out there. This is another concept that security people have really had to adapt to, and it's designing for elasticity. And elasticity is not something we're accustomed to at all. Even though we might have had a highly virtualized, converged environment internally in our data center, and if somebody clicked the button and said, I need 40 more instances running within my OpenStack configuration, I could do that. Okay, we've seen that. But what we haven't really seen is automated scaling and scaling back, and scaling and scaling back as a normal design principle for how our IT infrastructure operates. And it dramatically changes some of the things that security folks need to think through when you are putting together your security architecture. Simple stuff. Some of it is really basic. And it's annoying to even have to think about this stuff, but what about host-based tools that we have in place and the licensing? So you just went from 1,000 instances to 1,400 through some sort of a scaling operation that was totally approved and allowed. Well, what does that mean when all of a sudden that host-based agent you've got in place to protect you from, whatever, is now 1,400 licenses versus 1,000? Does that matter? Have you accommodated for that in your licensing agreements? That's the simple kind of stuff that you need to look at. You need to think about where those instances are. So if I had gone into your environment back in 2005 and run a scan and came back and said, guys, here's 1,000 instances or systems, and then I scanned that a couple hours later, scanned the environment, and you had 1,500 systems, would you have been concerned? Yeah. I mean, back in 2005, if you had 500 new things running in your environment that you couldn't necessarily explain, I would be concerned. Today, you can't be concerned about that. But what you do have to do is make sure that you know what caused those new instances or assets to be in place. So number one, think about things like licensing. Number two, think about where those assets are going to be spun up. Number three, and perhaps most importantly in that part of the discussion, you need to know what event spawned the triggering of those new assets in the first place and correlate that with the existence of the assets so that you're not constantly chasing your tail in terms of your SOC or your security operations team going, what is this that's happening in the environment and how do I track that effectively? Especially as you grow in scale and size, this becomes more and more paramount. Now, there is one last piece of this that we've got to take into account, and it ultimately comes back to how you've designed things, really mostly at a network level. But one of the really core architecture concepts that we've seen in the past couple of years that I've really seen most enterprises to some degree adopting is creating a central sort of zone, if you will, using something like an Amazon VPC or perhaps setting up a separate VNet in Azure, or whatever the case might be, and using that as the ingress-egress model for things coming into the cloud and leaving that. Because what it allows you to do is create almost sort of like a DMZ, but with your security appliances and logging and monitoring, all the same stuff that we're used to. But think about this. If you have this DMZ or this zone that's sitting in front of all of your cloud assets, or at least some of them, and behind those cloud zones that you've built, you now have double the compute running. Is that going to have an effect on the capacity that your security, appliances or whatever you've created are able to handle? The answer is absolutely. And so if you've got 10 systems talking, you've set up the bandwidth for that. If you've got 1,000 systems all of a sudden talking, and that's a ridiculous jump, and I know that, you are probably going to have to plan for this. So in those cases, security teams actually are now in a position where we've got to do more of like a vertical scaling. In other words, we've got to expand our capacity dynamically and automatically as we instantiate the triggered operations that led to the scaling in the first place. So maybe the point being, we have to scale too. So we've not only got to know what's going on in the scaling, but we've got to be able to scale accordingly at the same time so that we're not choking or throttling the environment. This is a pretty easy one in terms of just core design concepts. And what I find is that storage is not something that a lot of security teams spend a lot of time on, or maybe not really any time at all. They just don't tend to focus on this as much. But every single major infrastructure as a service design model that I've ever seen pretty much uses at least 2, 3, maybe even more different storage services within the cloud provider's environment, which means that it is intrinsically part of every single architecture that you're going to build or make use of. And for that reason, we've really got to take a look at what types of security options are available in those different storage options from the providers and keep track of that all the time because they're changing things regularly. So these guys are always announcing new capabilities, new services, new SLAs, new different redundancy options or availability options. All of that is on the table when you're designing the cloud because everyone's going to be hooking into this. So you know this. Common sense tells you this, right? You're going to be looking at things like encryption. You're going to be looking at the availability and the performance and all that kind of stuff, at least from a high-level standpoint. But because this is something that is 100% hooked in to everything that people are going to be building, it is really worth your while to add this as a continuous element of everything that you're doing and building because it is changing all the time. So at the last reInvent, Amazon announced the first completely by default encrypted storage option that they had ever had. Microsoft has had that for quite some time in Azure. You need to know those differences. And you need to understand how, of course, that ties into key management and everything else. So this is sort of the stock list of questions that I will often ask my clients and even some of my students as we're talking about this in terms of, look, what's the stuff that we need to be considering? Most of the time, cost is not really where we're focused as much as security folks, not for storage anyway. That changes if we're talking about storage for logs or the event data that we're collecting or that we're making use of. So if it's our storage, that's different. But in general, when people are designing for cloud, storage is everywhere. You've got to really make sure that you're thinking through what your options are. So this other sort of major design concept, which is a huge part of DevOps and DevSecOps, and architecturally, this is a major theme. So if you've ever sat through a DevOps session and people have talked about the concept of shift left and getting earlier in the pipeline and that whole thing, right? Some of you guys are probably pretty familiar with that. This is the other side of this. So shifting left puts you at the beginning of the pipeline as things are going through deployment and being pushed out. The other side of that equation is the right to left side, which is your feedback loop. And what this really means is something that I've really come to adopt in a governance strategy as well as an architectural and controls discussion. It's the concept of building a cloud that is already enabled with all of the event monitoring and sort of triggered events that you are going to need to tell you what is going on in that environment at all times. So one of the things I've found over 20 years in the security industry, and this is changing, which is good, we have a tendency to come in after the fact and say, here's all this stuff, we got to secure it. So you guys have set up a bunch of servers or different things. Let's come in and secure it. Got to get away from that. The first thing we have to do is, of course, try to embed ourselves earlier in the process. That's that shift left, sort of left to right model. But more than that, anytime somebody does a deployment, So when somebody puts something into the cloud itself, I want to know exactly what is happening the minute it shows up there. And I don't want to have to think about it after the fact. I may have to think about it if something goes wrong, if I'm designing for failure and I'm thinking through what that entails. But I've got to build out logging strategies. Now, logging is not an exciting topic. There are probably a few of you here that really like to talk about logging. I am actually one of those weirdos myself, so we could hang out. But logging is absolutely one of the most paramount elements of a cloud security architecture model. And what that means is you've got to look at a couple different places to log. And of course, your instances or workloads or containers, all of the above, they've got their own logs. Your applications have logs. It's not really the one that I'm focused on here, because we know we have to get those logs because that tells us what's going on with our actual assets and our infrastructure. The other piece of the logging design that is probably more important for this, right, really telling us what is going on in the cloud, is the control plane logging. Because that is exactly what you're doing, is you are pushing assets into a wholly software-defined infrastructure, all of which is connected to a singular control plane that is offered to you by the provider. That control plane is Amazon Web Services, and it's an account. That control plane is Azure, and it's things like subscriptions that are associated with your Azure account, et cetera, and on and on. What does that mean? It means I need to know everything that's going on in the environment. And the good news is, over the past, let's call it 3-4 years, all of the providers, every single major provider has stepped up in different ways and acknowledged the fact that you guys have to have this type of log and event data to not only know what's going on at all times, but to relay into automation strategies that build off of that. So these are just examples. And they really are just examples that I sort of threw up here. I could keep going. I'm not going to. It's really to illustrate that if you're talking about Google or you're talking about Microsoft or you're talking about Amazon, all of them have something. There's a little bit more work or pain involved in various types of logging, depending on who you're working with. You've still got to do something with that log data. And so it's great for me to stand up here and say, get all those logs. But at some point, you got to do something, which means you got to feed it off to an event management or some sort of analytics platform, something that allows you to dice through this and stuff and say, okay, what do I care about? What types of things are interesting to me? Do I care about every single event? No, probably not. A lot of it tends to be noise, but I still want to know everything that's going on, and then you can start picking and choosing what really makes the most sense for you guys to pay attention to and focus on in the long run. So everybody's got logs. You've got to make sure you turn them on. But remember, again, it's not just the logs from your assets and your application infrastructure. It's also logs for that control plane. All of it is equally important, and you've got to get it in terms of building out that feedback loop. So my last big concept as part of the major architectural design elements that I think you have to have in place for every single discussion is actually sort of 3 things in one. And I don't think any of them will be surprising to you, but I'll go ahead and explain my thinking as we talk about them here. And the first comes back to the concept of centralization. And I've seen this bite people. So I've seen large enterprises that have done a deployment years ago, started heading down the cloud road, decided they liked it, kept building, designing, putting things out into the cloud. And then eventually they ended up in a situation where they went multi-cloud, they have lots of different providers, and they're juggling operationally tools and processes that they never anticipated before, and it's just absolutely chewing things up. It's very easy to have that happen. And it sort of creeps in. Again, it happens sort of over time. What I would say is this. I would never say, hey, always pick the same vendors or always choose the same service providers. That's just not really ever a good idea for its own sake. You should always be looking at new and better and different technologies. And in fact, here at RSA, it's probably one of the best places you can do it all at once. But if you're looking at 2 providers of products or services, and all things being equal, they sort of do the same things, but one of them covers more in terms of cloud providers or their infrastructures than another, weight that heavily and appropriately, because it really does matter. If you're looking at a scanning vendor, or if you're looking at an endpoint vendor, or if you're looking at whatever kind of vendor or product you're thinking about using, really make sure you're thinking about that centralization strategy, because you don't want to find yourself with a hugely disjointed security operational model down the road. And it has really happened to a lot of my clients. The second piece is standardization, and this one everybody gets. Do not go off the rails on some crazy wingbat strategy that, never ever use vendor-created crypto if you can help it. Like, we know these things. But there's a little more to it, because there's some new things coming in to the sort of cloud side of the industry that I won't say is catching security teams unawares, but it's not stuff that we've traditionally had to deal with or been used to. And probably nowhere more than things like identity management and identity standards, particularly around things like federation. We've got to get used to these. We've got to get comfortable with them, even if you're not having to deal with them day to day in a hands-on fashion. If you're not comfortable talking about things like SAML assertions, if you don't know what they look like, if you've never heard of things like OpenID or OAuth, for example, you're going to miss out on some of the key parts of a design strategy that is rapidly becoming standard. So make sure you at least go out and take a look at these and understand where they apply or where they're maybe most appropriate for your organization. And there really is not one right answer, by the way. Number two, things like configurations. So going back to the idea of infrastructure as code and building that as one of our major sort of modalities for going forward, there's really two types of file standards that are being used over and over and over and over and over and over and over again for using infrastructure as code tools and processes. And that is, number one, YAML, which is what I've got listed here, which has a lot of different names, but the most popular is yet another markup language. You get it. But then there's JSON, JavaScript Object Notation, which is a parsable format for creating configuration details or data or sending it and transmitting it. And both of these tend to make their way into infrastructure as code and DevOps processes all the time. So get comfortable with these. Make sure your tools or scripts or whatever you're using day to day are capable of understanding this stuff, because it really is going to be more and more of a part of our lives going forward. The final one is automation. And automation, as I said right at the beginning of this talk, does not need to completely rule your life. Trust me, I just hear it constantly. I've actually had people give me snide, comments and remarks saying, if you're not automating to X level or percentage, you're falling behind. I don't know that that's really true. I mean, if you're talking to a cloud-first technology company that's based in Silicon Valley and has 17 people working out of a garage, you can automate the hell out of everything. Have fun. It's a great time for you guys, right? But if you're talking about a Fortune 50 global organization that is starting to really shift workloads into the cloud, but still got mainframes and still got all the other things that go along with the traditional enterprise, you can't just go automate your way to glory and think it's going to happen quickly. Pick and choose places to automate effectively. And nowhere is that more, really, I'd say, prevalent than the concept of that feedback loop I mentioned earlier. So you can get the logs. Logs are non-intrusive. They're a pain to deal with, and you may have to sort of condense or consolidate them because there's an enormous volume of it. But you can take that log data from the control plane, hone in on a particular event of interest, and say, that's weird. I'll tell you what I'm going to do. I'm not going to stop the presses. I'm not going to automatically quarantine things. I'm not going to automatically create forensic snapshots and all these other kinds of things. Those are all possible, by the way. So I'm very bullish on where automation is going in the cloud. But what you can do is you can apply a tag to an instance and then track it. That's an interesting instance. Let's just keep an eye on it. Or you can alert someone very easily as part of an automation strategy. So you can start in a more passive way and really build on that over time. And that's exactly where I see the successful teams really doing exactly this. So while not necessarily a core architectural principle, it's sort of an overarching theme. And it's one that the whole DevOps world has brought about, and I've really come to agree with wholeheartedly. It's this notion of managing what they call the blast radius, which is simply threat modeling in a lot of ways. It's us getting together and saying, what could go wrong? If it does, how bad could it be? And by asking ourselves how bad could it be, it allows us to take a step back and look at isolation mechanisms that prevent things from going dramatically, horribly off the rails, or at least to the best degree that we can build them horribly, terribly off the rails. So how do you do that? In other words, how do I prevent lateral movement? How do I prevent additional levels of account compromise if somebody does have an account hijack? Well, what's happening out there, and this is an enormously sort of busy slide, and I apologize for that, but we're looking at different ways to segment and create isolated nodes or compartmentalize things in our environments that is no longer the way we've done it in the past. So coming as a major architectural idea, I mean, if you go back again to the roots of security, it was networking, right? You built VLANs and subnets and access controls, and we put devices that blinked in various places to control things coming in and going out. We're still doing that to some degree, but more so than that, we're leveraging two additional elements that have changed the game, in my opinion. Number one is the use of identity policy to isolate and control who can talk to who. And so if asset number one is trying to talk to asset number two, even if they're in the same subnet and they live right next door to one another, the policy that is enveloping or encapsulating them and is basically attached to them prevents them from having a conversation. That is an identity principle. That is an access management principle. And that is something that security teams are really still coming to grasp in the way that they build and design things. The bigger picture here is even beyond that. And it comes down to the way that the cloud providers have built those isolation bubbles that you can make use of. And so if you're using subscriptions in Azure, or if you're using different accounts in some place like AWS, the account itself is an isolation mechanism. So is the subscription. And you can choose through more of an umbrella level identity and access tier policy to choose which ones can talk to which other ones. Wholly different in terms of how we build and design things. And so look, to wrap this up, and I might have time for 2 or 3 questions if there's a minute here. The way I would say today, and some of you guys might already be there, but if you're really just starting to get your hands around this, you should absolutely figure out, based on the things that I just talked about, how many of these things are you doing? How many of these different concepts have you incorporated into your day-to-day practices and processes for evaluating what teams are trying to build, coming to the table with solutions and architectural concepts that work? Within the first 3 months after this, I would say if you have not considered a multi-account or multi-subscription type isolation mechanism in the way that you're using cloud now, it's time to at least have that discussion. It is not easy. So that is another one of the things you'll hear out there. If you go to reInvent, some of these conferences, you'll hear people just say, you just use different accounts for everything. And then you know what you end up with? You end up with 400 accounts. And that's a problem just like anything else. It's not that easy to manage. So plan well, design for the appropriate use cases before you go there. Think about centralization, especially with centralization around infrastructure as code. Tools like Terraform are better for this. Doesn't mean that I'm, a shill for Terraform and the folks at HashiCorp. But if I said, well, look, I know I've got to go to 3 different cloud providers, and I also have a private cloud with OpenStack internally, is there something that can control all of that? There is. And you should consider using it. Within 6 months, like I said, is just sort of things to look down the road. I would say if you don't have a centralized deployment stream with an architecture team that has various, sort of inflection points along the way, building infrastructure as code, ensuring all of your images and builds and things are the appropriate ones, planning for failure of any of those components as well as architectures, that's where you should be. And also make sure, no matter where it ends up, you've already got that feedback loop in place. So I think we have 2 minutes left if anybody's got any questions, and I think there's a couple microphones that are going to be sort of lit up out here in the aisles if anybody's got any. 2 minutes. Go. This is your moment. Ask me anything you want. I am doing awesome today. Thank you very much for asking.
I guess I'm the lucky one. Great question. So let's say you have multiple clouds. You're using Azure ADFS, and you're also implementing Google Cloud. if you want to make the primary ADFS, what do you suggest to really go for that next step in ensuring there's no failover?
Well, it's a great question. And basically saying, how do you, I mean, you're talking about ADFS, meaning your own internal Active Directory, you're synchronizing out to various environments. Number one, make sure your internal directory services are always available, right? Because, I mean, obviously, if you're still linking back to your on-premises, that's a connectivity scenario. So you're federating, but how are you federating? Are you using a third-party provider that's in the middle of that? Are you synchronizing to like Active Directory in Azure? That's a pretty big question to try to answer without having a look at your architecture itself. But I'd say, if I had to gauge it, at some point, and it may not be now, you're probably going to ask yourself, are we going to be better off if we just shift the primary into the cloud versus doing it on premise? I'm not going to answer that question for you, but Microsoft will probably suck you into that black hole at some point anyway. Just wait, give it time. So I'm happy to talk to you offline about that too. Anybody else?
From a privacy and data ownership model, if you look at the roles and responsibilities, data and governance is always the owner or consumer of the service. So what kind of checks and balances, additional checks and balances would you take into account for that?
It's a good question. It's a big one.
Yes, it is.
And I think we're out of time, but I will tell you, it comes down to number one, asking the right questions of the cloud providers. You still got to trust them to some degree, and you got to read those invigorating SOC 2 reports that you know you love.
But the data is yours, though, so,
It is yours, but at the same time, you've got to have some geographic centricity that those guys are guaranteeing, which is typically a contractual scenario. I mean, you're not tracking your own data via some sort of, geotagging or something. So you've got to be able to ascertain that these providers are willing to contractually guarantee that, which means that if you're in multiple different regions, you're probably going to be limited to a very short list of providers in the first place. But it's another big question. I don't know that I answered it well, but it's a tough one.
okay.
And I think we're out of time, guys. So thank you very much for coming.